Autoencoders are neural networks which have to be trained. But we've also said that autoencoders are unsupervised learning techniques, which means they don't have access to a data set which is labeled. So, how does training occur for autoencoders when they don't have labeled data? Autoencoders are neural networks that seek to learn the most important features or the hidden latent factors in the underlying data. This they do by reconstructing the input at their output. Now, this isn't trivial, even though it sounds so, because autoencoders are constrained in several different ways, and they have to be able to achieve this reconstruction of the input in spite of the constraints. This is what forces autoencoders to find efficient representations of the data, just like with principal components analysis, which is why it made sense to study and intuitively understand what PCA was before we moved on to autoencoders. We've studied supervised learning techniques in some depth in this course. These machine learning algorithms seek to reverse engineer the function f that links the outputs with the input data. That means the training data set have the corresponding labels or the outputs, and supervised machine learning algorithms try to find a connection between the two. Let's say you had an image classification problem. You have the image of a bird and the image of a horse, and you feed it to a machine learning algorithm that is a supervised learning technique. And let's say the original predictions on these images were that it's a unicorn and a bat. We know that's not correct. This results in feedback to the model in terms of the cost function. This is what trains our machine learning model till finally it is able to predict that this is a horse and a bird. Autoencoders, though, have no labeled data to work off of. So you can imagine in this image problem, the images exist, but no corresponding labels exist. Autoencoders then try to learn the input itself. The process itself is unsupervised because there are no labels, but autoencoders very cleverly use the input itself to train an algorithm. It tries to reconstruct the input image to tweak its underlying model. So, for the very same problem that we saw before, if an autoencoder was your machine learning model, you would feed in the image of a horse and a bird with no associated labels. Notice that it would try to reconstruct the very same image. It may not get it right. What you see here is a horse and a plane, which is not clearly equal to the original image. This is captured in terms of a cost function. This cost function is used to tweak our autoencoder parameters till the model improves and it can as faithfully as possible reconstruct the input. It won't be perfect though because of all the constraints that we'll apply to this neural network. Now, on the face of it, autoencoders might not seem very interesting because x is equal to f of x. The function f is simply the identity function. But here is where the catch is. Autoencoders are constrained in some way or the other, and these constraints lead them to discover hidden patterns in data. Autoencoders uncover latent factors, the L, that actually drive our data. Without the constraints, it would seem like autoencoders could simply copy the inputs over to the output. But that is the identity function. That's not what we are looking for. We are looking for autoencoders to force themselves to learn the most significant features, the latent factors, which form the best representation of our data. The latent factors in our data will be of reduced dimensionality, which is why autoencoders are a kind of principal components analysis, and you can set up the autoencoder neural network in such a way to perform principal components analysis. This kind of dimensionality reduction is an unsupervised learning technique, and it serves as a preparatory step before a supervised learning step such as classification or regression. Dimensionality reduction helps us extract the most significant features in the underlying data, and these significant features can then be fed to other machine learning models. The dataset that you feed into the autoencoder neural networks for training do not have associated labels. Instead, autoencoders try to reproduce the input at its output layer. This reconstruction of the input under constraints, such as the number of neurons in the hidden layer or adding noise to the input of the autoencoder, forces the autoencoder to learn patterns in the underlying data to discern signal from noise.